The EIA Bridge Binder, Volume 3, Field Operations, and associated quality control forms in the field appendices specify that the abutment should be filled with stones, gravel, and grout in 30-centimeter lifts. This historically has been up for interpretation, and nobody, thankfully, is filling the abutments with soil anymore, but it can have a significant impact on design values. Therefore, it is important to clear up where and how we are getting these design values for abutment fill and what specifically we need to do to fill the abutments to achieve these design values. Now, the EIA Bridge Binder Volume 2, the design portion, recommends 1,900 kilograms per cubic meter as the abutment fill density for design purposes. This value should not change unless otherwise specified, and if it is changed, justification is required. Now, we can confirm the current value by the following thought experiment. So according to a 2008 study in the Geodevelopment International, compacted rock can get up to 2,400 kilograms per cubic meter with a vibrating compactor. However, blasted rock of varying diameters just dumped off a truck will have a density from 1,600 to 1,800 kilograms per cubic meter. This is on par with other estimates for crushed stone density. And moving forward, assuming cement mortar, which is the grout fill, has a density of 2,100 or 2,150 kilograms per cubic meter, confirmed by multiple other sources, we can calculate a conservative composite density for the abutment fill. Now, I've listed these values below down here, and all the associated studies that I've grabbed these values from are linked below this video. Now, crushed stone has a porosity or rather void space of 40%, according to structural backfill data sheets. But we'll take the binder estimate that only 15% of the voids are filled by the cement mortar grout. And in that case, our lowest or our composite densities are as follows. Doing a low estimate, we have, using all of the lowest values we've grabbed from above, we have in our 1,600 kilograms per cubic meter, 15% of that is filled with mortar grout, giving us 1,924 kilograms per cubic meter. And now for our high estimate, we have 1,800 kilograms per cubic meter, 15% of that being filled with 2,150 kilograms per cubic meter. We have 2,125 kilograms per cubic meter. Now, it's reasonable to assume that some compaction is happening, and as the masons will usually organize the stones by size, small, medium, large, and orchestrate the abutment fill as so to make sure that the maximum void space is used up by heavy material, and sometimes even organizing stones in the abutment after each lift and before placing the grout. However, it is more conservative to assume the 1,600 kilograms per cubic meter value if we can't confirm this is happening on site from a design perspective, and we'll take that lowest value of 1,924 kilograms per cubic meter to be our abutment fill density, rounding down to 1,900. That's where that value comes from. And like I mentioned, if we want to use any other value than that, there needs to be some sort of protocol that is followed or specified for the implementation team on site, and this needs to be justified by calculations as well.